This session is very important to watch from very start to end. Okay. You can directly expect question from this session, and we will be conducting also the problem solving session once the entire probability and statistics will be over. So you can expect huge learning from these sessions, right? So this session is really very important because many of us always struggle, uh, how do we compute probability whenever the joint density function is given, right? In case of continuous random variable, right? So if x and y are, jointly continuous, it means they will be described by the joint density function, right? So I urge everyone to watch this session, right? And you have to also watch the previous session. So let us begin the session here. In GATE 2024 and in data science and AI, one question was asked from this topic as well. And in electronics and communication, many times this kind of question has been asked, but many students struggle, as I can say. In fact, I was also struggling, right, when I was preparing for GATE. So you have to watch this session, and everybody has to comment on this video once the video will be over, and you guys will finish this video after learning something, right? Fine. So let us move and start talking. So this is lecture number 22, and we are discussing about the joint density function. Okay, joint density function. Okay, already we have discussed the conditional density function. So I think many of you may have understood what is the meaning of conditional density function, right? So I will just recap here. What is that conditional density function? Conditional densities. Okay, conditional density, right? That was nothing but suppose you have got a function, right? You can say, you will be having the joint density function. First of all, you have to keep in mind, right? So x and y be the are two random variables, okay, with joint probability, okay. So you should be able to find the marginal probability, okay, so that you can find the conditional density. See, I'm not talking about probability at this moment. See, density is different as well as the probability is different. You have studied probability, conditional probability mass function, for discrete random variable. But when we talk about continuous, so we always describe the continuous random variable with the help of density function, right? So in order to find conditional density function, you should be given the joint density function. ये आप याद रखना कि what will be given and what you have to compute, right? So joint density function. So there will be two random variable x and y. There can be multiple random variable, but we are restricting ourselves with the two random variable only. So two random variable will be given, whose joint density function will be given. Joint density function is denoted by like this, okay, x comma y. You can also write x times y, no problem is there, right? There are two random variable x and y. And then what you have to find out from this is you have to find out the marginal density function, right? Marginal density function. So this is nothing but your joint density function. Let me highlight. This is joint PDF, okay. From this, you have to find the marginals. You can find the marginal for x and the marginal for y. Okay, these are the unconditional, or you can say kind of marginal. Okay, marginal PDF. Okay, and then see, you must understand that why we are computing this marginal, so that you can get the conditional probability, not conditional probability, conditional density function. And why do we want to find out conditional density function? Because so that you can find out the conditional expectation, right? Okay, so these are the requirement. Okay, you have to remember the steps one by one, what you have to do, right? So this will be given, this guy will be given, you have to compute these things, and then you can compute the conditional density function. That is nothing but x given by you can say x given by is equal to the joint, that is x comma y, right? Okay, so the definition which I am giving you also, very similar to the conditional probability definition, but density is not straight away, defined as the probability, right? So if it is given by here, right, so we are conditioning on by random variable, okay, by can be, you can take by equal to A or by equal to B, whatever you want to take. So this has to be written as, so this is the marginal density function you have to divide. Okay, you have to divide marginal density function. Understand? So these are the steps that you have to follow always. Okay, please remember these steps. Okay. So I think this is clear, right? So what you have to do, xy will be the random variable with the joint density function, okay, and fx and fy will be the marginal densities. So what you have to do here is you can take this kind of a situation also, right? Suppose you have to find fy given a capital X which takes the value small a, right? Okay, this is the event, you can say. Okay, and then you have to find what? You have to find the density function. Okay, density function for by, already one of the event has happened, that is x equal to a. Understand? That is x equal to a. So so here it will be nothing but the function of by only now, because x is already known, right? Okay, so you can say that this is x comma by, okay, x comma by. Understand? And here x equal to a, and this is by upon, here you have to divide the probability density function of marginal density function at a. Okay, so this is how the conditional density function is defined, right? So if you will be given a joint density function, okay, so you can find out the conditional density function. Okay, I think this is clear. Suppose you have been given, and you have to make sure that this f of a must be greater than 0. This is very important. Suppose you are finding the conditional, you can say conditional density function for the random variable x, given that by equal to small b. So this will be the function of x alone, right? Because now the by is constant, by equal to b, right? So here you have to use the joint density function x comma b, okay, upon marginal density function, okay, for the random variable by, okay, at b. Okay. So I think this is clear, right? You have to always see this. So how can you find the density function? You can find the density function like conditional density function from the joint density function, okay? And you have to find the marginal. So I will take some example as well so that you guys can understand this, right? You guys can understand this, okay? So this is important, right? This is very, very important to keep in mind. And all those properties which we have discussed, like area under the density function will be 1, all those things you have to take care, right? That is very, very important to keep in mind, right? So what are the properties of conditional density function? So properties of conditional density function, both the conditional densities are valid density, okay? Like you have to make sure that the given density functions are valid density function, means area under the density function must be equal to 1, okay? And if suppose there are two random variable x and y, and if you are fixing one random variable, like here we have seen, we are fixing here y, okay, so this becomes the one dimensional conditional density function. Here we are fixing x, right? So whatever you are fixing, so that becomes the one dimensional, right? That becomes the one dimensional, you can say, right? In one dimension, right? You can say. Understand? And joint means what? What is the meaning of joint? Joint means the marginal times the conditional. Okay, that I have already discussed to you, right? Joint means marginal times the conditional. Okay, here I can write also joint PDF means the marginal times the conditional. Okay. Marginal times the conditional. This is important to keep in mind, right? So if you want to say that, suppose you have got x equal to a and y equal to b, right? Suppose you have got x equal to a, random variable takes the value a, and random variable b takes by takes the value b, right? Okay, such that you have to make sure that your fxa must be greater than 0 and f for the random variable by must be greater than 0. So you can define the joint density function x comma by, x takes the value a and b, right? You have to write the marginal here, right? Marginal, right? So marginal, you can write it is going to be symmetric, right? So remember that suppose we are writing x which takes the value a. So here you have to write conditional density function, okay, for the random variable by where x takes the value a, right? And this is nothing but uh, by takes the value b only, right? Understand? Or you can also say that fx x comma by which takes the value a and b is going to be equal to the marginal density function for by, and that takes the value b. Okay, here you have to take x equal x given that by equal to b and x takes the value a, right? So this is the definition. Okay, very easy definition that you have to remember. Okay, and how I'm writing these things, you should be able to understand that. Okay, from the very basic definition already we have discussed, so you should not face any sort of difficulty, right? So in general you can say, right, suppose x is not equal to a, by equal to not b, right? You can say x is equal to small x, and in general, okay, in general you can say that suppose capital X equal to small x and capital by equal to small by, capital by equal to small by, you can say, right? So your joint density function will be given like this: x comma by small x y. Okay, that is this is conditional now, right? So here you have to write by given x, okay, by given x. Understand, this is important, by given x. Or you can also write, needless to write here x, since x is given now, so you don't have to write by given x, right? Or you can also say that this is marginal density function, okay, that takes the value small by, and here x given by, and here you can write x only, since by is given, right? Since by is given, so you can say this, okay, you can write this is small x, this is small by. Okay, so I believe this is fine for all. Okay, so this is nothing but a joint density function. Okay, and joint density function is defined as the marginal times the conditional. And if x and y are you can say independent, that is very important property, as I told you also in the last session. If x and y are independent random variable, right? So independent implies symmetry as well, right? So if you want to describe the joint density function, so your joint density function is going to be the product of the marginal density functions, right, for x random variable and for y random variable. That is very important, right? So that is very important. So if x and y are what you can say that independent, if x and y are independent, then you can say that your joint density function is going to be written as the product of marginals. Okay, I mean this conditional, intuitively this conditional density function is going to be the marginals. Okay, your conditional density function will become the marginal. Okay, because whatever event has happened is not going to affect your further events, right? They are independent to each other. If x and y are what? Independent to each other, right? So please remember, independence implies symmetry, and it is going to simplify your life. Okay, it is going to simplify your life. Very simple. So I will take some example here. Okay, and already we have taken the uniform density function. We know that there are uniform density function, right? So first example I'm just going to take is example the uniform case. Okay, uniform, right? I think you guys are familiar with the unconditional density function, uniform density function, where if random variable is ranging from a to b, right? So your density function is going to be constant over that range. Okay, over that range. Understand? So please remember this point. Okay, so in that case, when the density function is given, right, so the support was what? Support was always, you can say, positive, right? Support was always positive. Keep this in mind. Support should not be equal to 0, right? Support should always be positive. And who describes the support? which information describes the support? I'm talking about region of support. Remember, this word is important, region of support. Okay, support is being described by the random variable, which random variable takes the value x on. Okay, जैसे मैंने आपको बताया था, अगर हम वन डायमेंशन की बात करें, so suppose f of x is given, which is defined as 1 by b minus a, where x takes the value b and less than a, right? Like this. Okay, so this is nothing but a support, guys. This is the support. This is going to describe the support. Okay, and you see here, support is always positive. Okay, it should be always positive. Okay, so if you're going to plot this guy, okay, so you can plot this, right? So this is nothing but a, and this is nothing but b, right? That is b minus a. So this is nothing but your density function, right? Your random variable is basically random variable is uniform. Okay, that takes the value between a and b, right? So your random variable is nothing but uniform random variable, okay, which takes the value a and b, okay, where the density function is constant. That's why we call it uniform density function, right? But here there will be two random variable x and y, so they will take two values. Okay, like x will take some value, y will take, so there will be range for x, range of y. Okay, and we are talking about discrete, we are talking about continuous random variable. That is very important. Okay, fine. So suppose we say that we are taking first example. A very first example is uniform on unit square. Okay, suppose x takes the value between 0 to 1, and y there are two random variable. Okay, you can say. So I'm talking about the very first example is nothing but it is going to be uniform on unit square. Uniform on unit square. Okay, so your region of support is going to be unit square only right here. So what kind of information will be given? X is uniform, okay, with 0 and 1, and another random variable is, it is going to be uniform in 0 and 1, right? So you can quickly draw the picture, right? You can quickly draw the picture. The picture is going to be this. This is x, you can say, and this is y. So your x takes the value 0 to 1, right? And y takes the value 0 to 1. So this is going to be your region of support. Okay, region of support should always be positive. That is very important to remember, right? Region of support should always be positive. Okay, ये आपको याद रखना है. So whenever density function will be given, you have to draw the region of support. Okay, before you start solving the question. So this is very basic. Okay, where x takes the value 0 to 1, there are two random variable. Okay, and y also take the value 0 to 1, right? So you can always draw, this is nothing but a region of support, guys. Okay, 0 to 1, 0 to 1, right? So if you want to find if you want to find the conditional density function, what is going to be the conditional density function here, right? Suppose we want to find the conditional density function, and here the joint density function is given. So how to find the conditional density function? Okay, that is very important to remember. So if you want to find the conditional density function, so first of all you have to draw the, this is the first step that is important. You can say 0 to 1 and 0 to 1. Okay, this is nothing but your x comma y x. Okay, this is the joint density function. Okay, and what you have to do here is, if you want to find by x takes the value small a, you can say, right? X takes the value small a, where a can be what? A can be between 0 to 1, right? You can say that a must be greater than 0 and a can be greater than 1, because x is equal to a, right? So we are fixing what? We are fixing x equal to a, right? So this is nothing but x equal to a. Okay, so we can go up, right? You see here it is constant only, right? Okay, if x equal to a, and x can go from 0 to 1, right? So what will be the density function, guys? Conditional density function will also be uniform only, right? I think you guys are able to visualize this. Yes, so suppose somebody is asking what is the density function, conditional density function for by random variable. given that x equal to a, right? So it is also going to be uniform because x equal to a, you are fixing x equal to a, and a can range from 0 to 1, right? Okay. And if you fix a x equal to a and you go up, right? So you are able to see that the distribution is uniform, right? So your distribution is uniform. So here you can also say that it is uniform between 0 to 1, right? It is uniform between 0 to 1, okay, where a takes the value 0 to 1, right? Suppose you are trying to find the conditional density function where x for the random variable x, where y takes the value small b, right? Where y, so this is also here b can be what? So y is taking this, you can say this is b. So you see here, okay, so you know that this density function again taking the value 1 only, right? Okay, you see between 0 to 1. So b is lying between 0 to 1 and this is uniform 0 to 1 only, right? Okay, so you see conditional density function is also coming out to be uniform whenever unit square is given, whenever you find the region of support as unit square. So life is very simple, okay? And why we are getting unit square here? The unit square we are getting because x can take the value 0 to 1 and y can take the value. So we are able to sketch this region of support, okay, in two-dimensional plane. See, we can't draw the three-dimensional plane, right? I mean three-dimensional picture, okay? Because for 3 dimension, 1 dimension also has to be introduced, right? So you just consider 2-dimensional, okay? And this is uniform. Okay, so you can quickly find out these conditional density function, and if you are able to get the conditional density function, you can find out what? You can find out the expectation. So here you can find out the expectation using this. Okay, I think this is clear for all. So this is the very important first case. Okay, first important part, right? And let's say somebody says that. Okay, example number 2. Suppose somebody says that x comma y, these are the two random variable, okay, which is uniform in certain region. In certain region, you can see, in particular region it is uniform, right? Uniform in certain region, you can say D, okay? It is uniform in D. Okay, x and y are uniform in D, and this D can be, you know, D, and let's say D is given like this. Okay, D is nothing but a particular, you can say, area. Okay, D is going to be a particular shape, okay, in which this x and y, your density function is going to be uniform. Uniform means if you fix something, the distribution for another random variable must not be different. Okay, that should be same. Okay, constant. Okay, so if D is given like this, this is region is defined like this. Okay, it is not unit circle now, sorry, unit square, you can say. It is going to be like this. Suppose x takes between 0 to 1 by 2, and you can say that y takes the value between 0 to 1 by 2, intersect, you know, this union 1 by 2 to 1 into you know, y takes the value 1 by 2 to 1. So this is D. Okay, we have defined this D. Okay? And inside this D, right, remember, we have to always look uniform density function inside the region of support. Okay, आपको बाहर नहीं जाना है, बाहर तो जीरो होगा ना रीजन ऑफ सपोर्ट, बाहर डेंसिटी फंक्शन विल बी जीरो. ओके, outside the region of support, okay, this is important point, outside the region of support density function will be 0. And who is going to decide the region of support? The range of x and y. ठीक है, now can we draw the picture here, guys? देखो, drawing the picture is very important. Okay, drawing the picture is very important. देखो मैं draw करता हूँ. Suppose this is the x axis and this is the y axis. We are drawing on the two-dimensional plane. So x takes the value 0 and y, you know, and it takes 1 by 2, and y also takes, so this is 1 by 2, right? So you can say this is one region, okay, one specified region in which your density function is uniform, right? This is, you take x equal to, you know, x equal to something, you can say x equal to a if you are taking, So A can take the value between 0 to 1 by 2, but it is constant, right? It is uniform. And next is, it is also taking 1 and it is also taking 1. So you can say that this is the picture, right? So these are the region of support. You see, are you able to draw this kind of a picture? Yes, you can draw this kind of a picture, right? So region of support is very important to draw. And if you're not able to draw the region of support, then life is very difficult. Okay. So if you want to find the conditional density function, right? Suppose you want to find conditional. I will compute the probability as well, but at this moment try to compute the conditional. ठीक है, क्योंकि आपके एग्जाम में कंडीशनल एक्सपेक्टेशन पूछा जा सकता है. सो हाउ टू फाइंड कंडीशनल एक्सपेक्टेशन if this kind of a density function is given. Suppose let me fix x equal to a here. So by given that x equal to a, right, by given that x equal to a, and let's say x takes the value between 0 to 1 by 2. अगर मान लो x क्या करता है, it takes the value between 0 to 1 by 2. So it is going to be uniform only. Now you see, it is uniform, right? I'm looking at inside the region of support. Okay, I'm looking at region of support. So this guy is going to help you to draw the region of support, guys. ठीक है, तो यहाँ पर आपका यूनिफॉर्म ही रहेगा. This is uniform between 0 to 1 by 2. Okay, it is going to be uniform only. And if I say that if I say that A can take what, A can also take if A can take between 1 by 2 to 1, so here the density function is, conditional density function is again uniform only, right? But it is going to be between 1 by 2 to 1. Okay, between 1 by 2 to 1. Okay, so I think these two computation is very important. This is the first computation that you can do. Next is you can also fix b by equal to something. Okay, by equal to something, right? And you can find out. Okay, suppose we are finding the conditional density function for x given that by, so it is b can take the value what, we can initially take the value between you can see here between 0 to 1 by 2, and we can also take the value between 1 by 2 to 1, right? So here it is gonna be uniform. Okay, so if it takes the value you can say that b takes the value between 0 to 1 by 2, then what is going to be okay, I think this is clear, right? So this guy will be between 0 to 1 by 2, right? And then for this it is going to be uniform between 1 by 2 to 1. ठीक है, so please do remember these points. Okay, it is going to be just uniform only, right? And how we are finding this, because of by, yeah, okay, just by looking at that. ठीक है, let me take more uniform examples, right? So these are the uniform example I'm telling you, right? These are uniform examples. Inside that, inside the region of support, the distribution is uniform. यूनिफॉर्म को मतलब क्या है? Inside the region of support, the distribution is uniform. Okay, and the support must be always positive, right? Support ऐसा हम लिखते हैं, support x comma y must be greater than 0, guys. Support must be always positive, and this support is going to give you some kind of a picture, right? You have to draw the picture. आप picture सबसे पहले draw करोगे, ठीक है? Let me take some more examples just to understand this. ठीक है? देखो ये example समझना important है. If you are able to find these examples, so in the question, when problem I will do, you will be able to understand everything. ठीक है? So suppose we say that the random variable x and y, they are uniform in the region, in specified region, uniform in D, and this D is given, right? Okay, this D is given where D is equal to, right, D is equal to 1 comma 3, okay, D equal to 1 comma 3 into 0 comma 4, okay. So can you draw the picture here? Yes. So yes, we can draw this. So this is X, this is Y. So here you see guys, you see X can take the value between 0 to 1, 0 to what? 0 to, sorry, 1 to 3, not 0 to 3. This is X and this is Y, right? So X is taking the value between 0 to 3 and Y is taking, you can say that this kind of picture. Okay, 0 to 4. Okay. How to sketch that, please remember. Okay. I hope this makes sense, right? So it is also again uniform. If you take X equal to A, right, it is going to be uniform only, yeah? This is for X and this is for Y. Okay. This is for X, this is for Y, this is for X, this is for Y. Okay. These ranges, right? So it is again uniform. It is uniform. And you can easily find out the expectation, conditional expectation. You can easily find out the conditional density function. Okay. So please remember these examples. Let us go to take next example for uniform only, right? And your X and Y, your distribution is uniform in particular region, right? Suppose I say that random variable X and Y is uniform, okay, in D. Now where D is going to be what? This D is going to be 0 to 1 into 0 to 1 union, okay, 1 comma 2, okay, and 0 to 2, okay, 1 comma 2 and 0 to 2. So can we sketch this picture as well? Yes. X comma Y, you should be able to sketch this picture. See, this is one way of giving the inequalities, right? This is inequalities only, guys. Okay. A region of support will be given in terms of inequalities in the question, right? Or they might give this kind of a region of support, or they might give you inequalities, right? Inequality matlab jaise X is lying between 0 to 1, right? Y is lying between, you can say 0 to 2, like this. Or so first is unit square, right? 0 to 1, 0 to 1. So first is unit square. Okay. आप बोल सकते हो ये unit square है 0 to 1, 0 to 1, right? This guy gives us 0 to 1, 0 to 1. Next is 1 to 2, right? 1 to 2. So X is changing from 1 to 2 and this guy is changing from 0 to 2, right? So you can say that this picture. So this is nothing but the region of support. And if you take any value of X, right? If you take any value of X, suppose you take X equal to A here, and A lies between 0 to A. So it is constant, it is uniform. If you take here X equal to A, where A can take the value between 1 to 2, so it is again constant, right? So that's why we call it uniform. This is uniform density function. Yes. I'm pretty sure that nobody might have gone through this kind of concepts, right, in their gate preparation, right? So ये important है. पहले आप सोचो तो. See, they might give you this similar information like this also. X lying between 0 to 1, okay, and Y lying between, ऐसा भी दे सकता है. Same information को कैसे दे सकता है? X, Y 0 to 1, right? ऐसा दे देगा, फिर यूनियन बोल देगा, right? 1, 2, okay, ठीक है. X lying between 1 to 2 and Y lying between 0 to 2. ये inequalities के फॉर्म में भी दे सकता है, right? So you know, in general aptitude I will teach you inequalities, right? So if you are not familiar with inequalities, So you have to watch my lectures on general aptitude. ठीक है? So देखो, sketching a function is very important. That makes your life far easier. ठीक है? और आप कॉन्फिडेंटली गेट के क्वेश्चन कर सकते हैं. अगर आप रट के जा रहे हो तो लाइफ टफ है. And this uniform in certain region, okay, some particular region we are talking about inside the region of support. ठीक है? We can take one more example if you want. Okay, so let me take one more example. This is one, these are the examples, please remember. ठीक है? ये बहुत important example है. Now you may be thinking that how, sir, it is uniform. I will say, tell to you, right? Suppose you have been given a random variable, you can say x comma y. We say that this is uniform. Uniform inside, you can say, the region D, right? And where D is given like this in terms of set builder form, okay, like in terms of sets, okay, that is given as small x and y takes the value such that, okay, such that x plus y is less than 2, okay, such that x plus y is less than 2, where x is greater than 0 and y is greater than 0. This is important, right? Okay, understand? So this is given. Okay, they might give you also that key your x and y are natural numbers. They might say like this also. So now you have to sketch this part. This guy you have to sketch. Okay, this D you have to sketch first, right? Before you start computing the probability, right? Before you start computing anything, right? You have to draw these pictures. Okay, that is my main idea. Okay. At this moment we are not computing probabilities, we are just sketching the region of support, right? So पहला केस मैंने आपको यूनिट स्क्वायर बताया था, where x was taking 0 to 1, y was taking 0 to 1, simple unit square, right? Okay, and I will tell you how to compute the probability as well. So conditional density function कैसे compute करते हैं, conditional density function and marginal density function, all these things you should know first, right? Now can you tell me how to plot this guy? So first of all, see, it is given like this, x plus y less than 2. So first of all you have to draw this, okay, like you have to take from here x plus y equal to 2 and draw this picture. What is this? X and y, right? So x plus y equal to 2 means what? X, if x is 0, y is gonna be 2, right? And if, okay, so this guy is 0 comma 2 and this guy is 2 comma 0, so you can just join these lines. Okay, these 2 points. Yeah, this is the region of support, guys. Are you able to see this? This line is nothing but what? This line corresponds to x plus y equal to 2. Now how I am getting this line is from this inequality, right? ये inequality जो दी हुई है question में. So if I ask you what is x, suppose if I ask you x equal to a, here x can take between 0 to 2. X is always greater than 0, so that your support will be positive. So if x equal to a, what is going to be y, guys? You see, y is always constant, right? That is 2 minus a. Yeah. Here y, you see your density function is constant. Yes. Your density function will be constant. Understand? If x equal to a, your density, that is the reason it is also uniform in D. It is uniform in D only, right? X and y are uniform in D. Okay. Your density function, joint density function is gonna be uniform in D. Okay. You take x equal to a, anything you take. Okay. You can write, please write all conditional density function by yourself. Take x equal to a, fix x, fix by, okay. Find out the conditional. Your job is to find out conditional, okay, density function, okay, like fix x equal to a, fix x equal to y equal to b, right? For all question whatever I have taught, अपने से करिए, है ना? कर सकते हैं ना? इसमें भी आप करिए, यहाँ पर भी find conditional, right? X given that y equal to b you take, and okay, that will be uniform. Okay, that will be uniform. Your conditional density function will be uniform, right? So ये सारी चीजें आपको करना पड़ेगा. Okay. So you can also write analytically. You can write analytically. Okay, you can plot. Okay, if you have got the conditional density function, you can plot it, right? Suppose let me tell you. Okay, for this picture, मान लो हम इसके लिए प्लॉट करना चाहते हैं कंडीशनल डेंसिटी फंक्शन. आई मीन आई जस्ट वांट टू राइट एनालिटिकली. ठीक है. सो आप देखोगे यहां पर कि x इज टेकिंग सी बाय given that x is equal to a, where a is taking between what 0 to 2, right? So this is uniform in 0 to 2 minus a, right? It is uniform between 0 to 2 minus a, right? Because by can take 0 to minus a. So can we plot this guy? So you will say yes sir, since it is uniform and now it become one dimensional now, right? It is one dimensional because x equal to a is fixed, right? So you can also write this as by x equal to a, here by. Now your by takes the value between, you can say 0 to 2 minus a, right? It is gonna be 1 by 2 minus a and 0 otherwise. This is the analytical formula for conditional density function. And you can plot it, right? So how to plot this guy? I think everybody knows, right? So 0, this is by only, x equal to a, 2 minus a. ठीक है. And we have to make sure that the area under the density function is 1. So I believe now from the given joint density function, you guys will be able to find the one dimensional, I mean, you guys will be able to find the conditional density function. Okay? From the conditional density function, you can find out the conditional expectation. ठीक है. अब इसका कोई पूछेगा conditional expectation क्या है, आप क्विकली बता पाओगे. And in case of uniform, life is very simple. As long as your density function is uniform, life is very simple. Computing expectation बहुत easy होता है. ठीक है. So you have to watch these sessions very carefully, right? Very, very carefully. Okay. But you will get kind of a problem. Let me tell you, you will get kind of a problem, right? Where the density function is not going to be uniform, guys. I'm just going to give you the example, right? Suppose you have got a question of this kind. Okay. Suppose you have got a question of this kind. That is, this is a question. Okay. This is a question. Okay. Yes. So you can find conditional here also, but can you tell me whether the density function is uniform? No, it is not uniform this time, because your conditional joint density function, if you look at x by, okay, you can say that x by, x comma by is given as x plus by. It is not unit circle, or you can say that, okay, see, region of support is uniform here. Okay, x and by, they are taking the value 0 and 1, right? But this guy is not uniform. It is given some different structure, right? You can say it is very important to remember, right? Yeah, it is non-uniform case. Okay, it is non-uniform. Yes. Now, how to identify it is non-uniform, guys? कैसे पता चला हमें? How Dheeraj sir came to know about it? Since joint density function is a function of x and by, your region of support is uniform, no problem, but the density function is not uniform, right? So if you want to find the marginal density function, see, now in this case you can't directly find out the conditional density function from the joint directly. You can't find out, remember. जैसे मैं अभी कर रहा था कि we were just fixing x equal to a, because that was uniform case. ठीक है. आई बिलीव यू गाइज आर एबल टू अंडरस्टैंड नाउ, ठीक है। जैसे आपके गेट में इन गेट 2024, ओके, लास्ट टाइम आई टुक क्वेश्चन आल्सो, ठीक है। In gate 2024 there was a question, fx by x comma y is equal to 2xy. That was not uniform guys, uniform density function, right? Okay, तो आपको समझना पड़ेगा कि अच्छा ये यूनिफॉर्म का नहीं है, ठीक है। when analytical formula is given, okay, then you will be able to identify, yeah, it is not uniform, right? So then if you want to find conditional density function, you have to find the marginal first, right? और मार्जिनल फाइंड करना बहुत ही सिंपल है, ओके। आई होप दैट मेक्स सेंस टू यू, ठीक है। सो लेट अस कंप्यूट मार्जिनल फर्स्ट। तो मैं यहां पर कमेंट भी लिख देता हूं, एज लॉन्ग एज इट इज नॉट इट इज नॉन यूनिफॉर्म, ओके, इन द रीजन, इन दिस रीजन, ओके, इनसाइड द रीजन ऑफ सपोर्ट, inside the region of support, right? Therefore we cannot find conditional directly. Okay, first step will be what is the first step guys? Step number 1 is find marginals. Find marginals. ओके, सबसे पहले आपको क्या फाइंड करना पड़ेगा? मार्जिनल फाइंड करना पड़ेगा। फर्स्ट स्टेप इज फाइंड मार्जिनल। सो व्हाट इज दैट मार्जिनल? तो एफ एक्स, so if you want to find the marginal density function for x, so you have to run the integration over by, and you can draw the region of support as well. Region of support is going to be, you know, x comma by 0 to, it is unit square only, it is given as unit square, unit square. This is the region of support, okay, it is given as unit square. I can plot here as well, 0 to 1. Now what you can do, you have to if you want to find out marginal density function for x, so what is the limit of integration that you will take? That is, you have to use the integration here, right? So by changing from 0 to 1, and your density function is x plus by joint density function, and you have to, you have to what, you have to integrate over by, right? So इसको आप अगर करेंगे तो x by plus by square by 2, 0 to 1, in place of by you have to put, so it becomes 1 by 2. Okay, now if you want to find out marginal density function for random variable by, so again 0 to 1 only, x plus by, though you can write this directly. Now you can write this directly. How can you write directly the marginal density function for x, since it is going to be what, it is going to be symmetrical, right? Okay, see, by symmetry you can say that, okay, by symmetry you can say that it is going to be symmetrical, okay? Because your region of support is uniform, 0 to 1, 0 to 1, it is uniform here, right? Density function is not uniform, so you can say, but fine. So if you try to compute this, so it becomes x square by 2 plus x by, putting the value 0 to 1. We can use the fundamental theorem of calculus. So here 1 by 2 plus by, where by takes the value between 0 to 1, right? In this case x takes the value, here by takes the value between 0 to 1. In this case x takes the value between 0 to 1. Okay, equality does not make any sense in case of continuous random variable, तो आपको ये समझना पड़ेगा. So you got this marginal, right? You got this marginal. Now if you want to find conditional, Step number 2. Okay, finding conditional. Finding conditional, right? So if you want to find conditional, guys, suppose you want to find, by given x equal to a, okay, where a can take the value between what? If x is equal to a, means x can take the value between 0 to 1, because x can range from 0 to 1, means a can also range from 0 to 1. Okay, now we have fixed x, so that is a plus by, okay, that is a plus by, understand? And what is marginal? Marginal is here, you have to divide what? You have to divide x plus half. X takes the value a plus half, right? Understood? You see, now your conditional is also not uniform, right? Where y can take value 0 to 1. I think this is the first step that you can do. And the second step that you can also do is, x by equal to b, where b can take the value between 0 to 1. This is a function of x. So this is going to be, now x plus b upon b plus 1 by 2. It is not constant, right? Remember, x takes the value 0 to 1. By symmetry, you can say. Okay, by symmetry, we can write like this, yeah? Okay, so I believe this is fine for all, right? So it's a very simple concept that you can understand, yeah? So my main objective was to tell you how to find conditional density function, not the probability, right? How to find marginal density function. So whenever the uniform densities are given, joint density, your job is very simple. But suppose density function, joint density function is not uniform, then you have to use the integration. And integration is going to be very simple. And you can also plot it, right? If you want to plot it, you can plot it, right? Suppose इसको अगर आपको plot करना है, इसको आप plot कर सकते हो ना, ऐसे. This is, by is taking the value between 0 to 1, right? This is f by given x equal to a. Okay. Now at 0, if you plug by equal to 0, right? So this becomes a by a plus 1 by 2. And if you plug by equal to 1, right? So this becomes the point here. That is a plus 1 by a plus 1 by 2. Oh. So this kind of a situation you are getting, right? You can also plot it, right? Yeah. So plotting is also important. If you want to plot it, you can plot it, right? So you are able to see that it is not uniform, right? Your conditional density function is also not uniform. Yes? So ये कुछ important points हैं जो आपको पता होना चाहिए, while studying these things, you should know that. So इतना easy तरीके से समझना बहुत जरूरी है, ठीक है? Okay. Part 2 will also come. ये part 1 है, region of support, ये सारी चीजें. और as long as the two random variable section by are independent, right? So their marginals are multiplied, right? You can take the marginals and multiply them. ठीक है? Okay. So this is important to remember. Okay. In the exam, whenever joint density function will be given, right? Okay. So if you are able to factor joint density function into x parts and the y parts, okay, x part and the y part, okay, then that density function, like you can say that x and y random variable is gonna be independent, right? ठीक है, मैं आपको बताऊंगा. Without computing the marginals also you can decide if region of support is given, right? If region of support is given, based on the region of support, you can decide whether this is going to be independent or not. I mean, random variables are independent or not, right? So important to remember this theorem. Okay. So what is this theorem says? The x and y are, independent, right? Two random variables are independent if and only if their joint density function will be the product of marginals. ठीक है, वैसे आपको पता ही है कि ज्वाइंट का मतलब क्या होता है. ज्वाइंट मींस the marginal times the conditional, right? So given the joint density functions, you can find the marginals. What are the things that you can do? Given JPDF, you can find marginals, right? And if joint density function is the product of marginal density function, then x and y are independent, you can say. Okay. And if independent, right, the marginal determines the joint density function. ये भी याद रखना. If independent, then marginals determines the JPDF. Suppose in your question, joint density function is given. Sorry, not joint. Marginal density function is given, and you have to find joint density function. If they are independent, directly multiply them. Okay, that gives the joint density function. You have to make sure that joint density function must be, that joint density function must be what? That is very important to keep in mind, right? That joint density function must be Balic joint density function, that is area under the joint density function must be 1. ये सब चीजें आपको करना पड़ेगा. ऐसा नहीं है कि धीरज सर ने बता दिया that is final. Okay, you won't believe. I spent every day on probability. I spent a lot of time on probabilities. I spent a lot of time on single concept to tell you. आपको ऐसा लगता होगा कि डायरेक्टली सर को पता है, ऐसा कुछ नहीं है. ठीक है. Okay. So let me take some example just to directly prove. Suppose you have got a region of support that is given as uniform, right? Suppose people say that x and y are uniform 0 to 1, right? Now question is, are x and y are independent? It is joint density function is given, right? आप ऐसा ड्रॉ कर सकते हो पिक्चर. रीजन ऑफ सपोर्ट, दिस इज रीजन ऑफ सपोर्ट, राइट? 0 to 1. Now are x and y independent? Question. So what will be your answer? You will say yes. What will be your answer? Yes. Why yes? Because you can see here. You can see here. You take any value of x, right? You take any value of x. X is going to be between 0 to 1. Y is going to take 0 to 1, right? So they are symmetrical, right? Yes. So it is independent. And you can also say that x does not depend on y does not depend on x. Okay. In the region of support, if you look at the limit, right? 0 to 1, 0 to 1. So x does not depend upon y. Both are independent, right? Okay, so. Okay, and it is uniform. It is uniform. Okay. Yes. So please remember this. This is independent. Directly you can prove. If you try to find the marginals, you can find out. But it is independent, right? You fix x equal to a, you're going to get the y which is uniform. If you fix y equal to b, you're going to, and then, yeah. It does not depend upon x or y, right? Okay. Okay, your density function should be uniform, guys. Okay, density function should not change. Okay, if density function is changing, right, then it will not be, independent. Okay, if density function, if you are changing x, so your density function should be same, it should not change. ठीक है, अगर आपका डेंसिटी फंक्शन चेंज हो, डिस्पाइट इट इज यूनिफॉर्म इन सम रीजन, बट इट इज चेंजिंग फॉर डिफरेंट वैल्यू ऑफ एक्स, then it is going to be dependent, right? For different x, your y is different, right? Okay, what I'm trying to convey here is that suppose आपके पास ऐसा रीजन है, और suppose you have got this kind of situation, I'm just going to tell you it. मान लो आपके पास ऐसा दिया है, some question I can take directly. These questions you see. So the first is independent. Okay. Second is not independent. Third is what? Third is independent. Okay, you have to see inside the region of support, right? It is independent. Certainly it is independent, right? See, it is not uniform on the, like you can say, it is not a unit square, but it is uniform and it is independent. Okay. You take any value of x, your y is gonna be independent, right? It is, okay, it is same. It is not depending upon your value of x. Okay. Okay. Next is fourth one. You can see this is not independent. By looking at the region of support, this is region of support. I'm just looking at this. Independent, what is independent? X and y. You have to remember x and y. X and y. See, density function independent नहीं होता. X and y are independent. Okay. इसमें देखो not independent. इसमें देखो not independent, because depends on x and y value. इसमें क्या है? See, if you look at the region of support, right? If you look at the region of support, clearly it is saying that it is uniform. Region of support is uniform, right? But the density function is not uniform, right? So this is not independent. Okay, you're not independent. Okay. So I think this is clear for all, right? So we'll meet in the next session, guys, and we'll conduct more concepts, right? There are many other concepts that I have to discuss. Okay, I have to talk about how to compute probability. Next concept, right? वो बहुत इंपॉर्टेंट है, बहुत सारे क्वेश्चंस आए हैं. गेट डेटा साइंस एआई का क्वेश्चन भी हम लोग करेंगे इमीडिएटली आफ्टर द कंप्लीशन ऑफ द क्लास. So I hope you might have enjoyed the class. Please remember this. ठीक है? We'll meet in the next session. Thank you.